So this week we are going to be working on solving one-step equations. It is a concept that we are building upon. It is a very important foundation for algebra. In the higher maths that you're going to take, you need to know how to solve equations. And this also includes in daily life. You solve equations all the time. You just don't realize it or think of it in that way. All right, so let's start. An equation is a mathematical sentence with an equal sign. The following are all considered to be equations. 9 plus 2 is 11. 11 equals 11. X plus 7 equals 37. A plus negative 3 equals 2A plus 5. So these are equations because of that equal sign. When we have expressions, those are mathematical phrases. They don't have restrictions, as in your variables can literally be any number that your heart desires. With equations, it puts a restriction that your variable can only be one number to make it true. So for the second example, x plus 7 equals 37, there's only one number that could possibly make that true, and that is 30. A solution of an equation is a value for a variable that makes an equation true. You substitute a number for a variable to determine whether the number is a solution of the equation. And that is your checking solutions worksheet. All you had to do was take the number that they gave you and substitute it into the equation to see if it worked out correctly. If the left equaled the right, it was a solution. If the numbers didn't equal each other, it was not a solution. All right, so here are some examples. Directions. Is the given number a solution for the equation? Please show how you arrived at your answer. So again, all we have to do is check to see if the numbers they give us work. So for 170 plus x equals 200, we're going to substitute 30 in for x. So you get 170 plus 30. Well, that is 200. 200 does equal 200. So yes, x equals 30 is a solution. Now for the second example, 3 equals 12 minus a for a equals 6. So again, we're going to substitute 6 in for a. 3 equals 12 minus 6. 12 minus 6 is 6, and 3 is not equal to 6, so no, a equals 6 is not a solution. Next example, 9 minus m equals 3. It wants to know if m equals 6 works. So we substitute 6 in for m. 9 minus 6 equals 3. Well, 9 minus 6 is 3. So yes, this is a solution. Try and get rid of that so you can see it. 8 plus t equals 2t. Well, that's 8 plus 3 equals 2 times 3 because we're substituting 3 in for all the t's. Okay. Well, 8 plus 3 is 11. 2 times 3 is 6. 11 is not equal to 6, so no, t equals 3 is not a solution. Important rules for solving equations. Rule number 1, when you solve an equation, your goal is to get the variable alone by itself on one side of the equation. It doesn't matter if it's the left side or the right side, you just want the variable to be by itself. This is called isolating the variable. So we are trying to isolate the variable. It wants to be alone. Rule number 2, when you are solving for a variable, you must use inverse operations, right? So if you see addition, you use subtraction. If you see subtraction, you use addition, and vice versa with multiplication and division. Whatever you do to one side of an equation, you have to do to the other side of the equation, and this keeps the equation balanced. All right, so when we're solving an equation, it's like lifting weights. All right, so this is a barbell, and if you've never lifted weights before, if you add or take weights away from one side, you have to do it to the other. If not, you're going to severely injure yourself because it won't be balanced. Something you might be more familiar with is a seesaw. If you've ever been on it, you know, when you go on it with someone who has a different weight, you go up and down, up and down. If you've ever been on a seesaw with someone who's about the same weight as you, you can actually balance it so that it's level. And that's what we want. We want to balance the seesaw so that it's level and we're not teeter-tottering up or down at all. Right, when we are solving the equation, we must use the inverse operation to isolate the variable on one side of the equation. If you add or subtract from one side, you must add or subtract the same number to the other side. So here's this first example. We have x plus 4 equals 6. You can probably look at it and say the answer's 2. That's great. I don't care. What I care about is you being able to determine what the variable is, what operation is with the variable, what is the inverse of that operation in order to isolate the variable. Okay, so in our example, x plus 4 equals 6. My variable is x. I need to get that by itself. The plus 4 is in the way of that happening. The opposite or the inverse of that is subtraction. So I'm going to subtract 4 to both sides to keep it balanced. 4 plus 4 is, or 4 minus 4 is 0. 6 minus 4 is 2. So that's how we get x equals 2. If you want to check, you can always substitute your answer back into the original equation. 2 plus 4 is 6, so you are correct. For the next one, we have y minus 5 equals 12. Same thing, y is my variable. I'm trying to get y by itself. Then minus 5 is preventing that from happening. I'm going to use inverse operations. The opposite of minus 5 is plus 5, so I'm going to add 5 to both sides. These 5's cancel out, so I'm left with y, and 12 plus 5 equals 17. And again, you can plug 17 back up here to see if it works. 17 minus 5. Yeah, that's 12, so we did it right.